Hello everyone, my name is Tavian Robinson and I currently have my bachelor's degree in cybersecurity and my software development certificate from Springboard. Today I'm going to walk you through the process of setting up an IDS using snort, configure detection rules, and demonstrate some common attack simulations using Kali Linux. Let's get started. The goal of this project was to set up snort on an Ubuntu server and use it to monitor network traffic from my Kali Linux. I created custom rules to detect various attack patterns, including SSH attempts, ICMP pings, and flood attacks. First, I installed Snort on my Ubuntu server. This involved download Snort, configure the Snort configuration file, and define our network variables. Next, I set up Kali Linux virtual machine on the same network to simulate different attack scenarios. I began by creating some basic Snort rules to detect specific types of traffic. Here are a few examples. For SSH detection, we created a rule that triggered an alert if there's an SSH attempt from a single source. For ICMP ping sweeps, which involve scanning the network to find active hosts, we use the second rule that alerts when SSH attempt. And to detect flood attacks, which generated a large amount of traffic to or more on a server, I created the rule on the bottom to detect flood attempts. I then tested these rules using friendly traffic to ensure that they worked as expected. First, I pinged the Ubuntu server that created ICMP ping, which tested the network connectivity between both machines. Now let's move on to some attack simulations. Using the Kali Linux VM, I conducted 3 types of attacks. Using FTP ping, I conducted a ping sweep to identify live hosts on the network. Snort picked it up rapidly and generated an alert. Next, I used HPing3 tools to generate a high volume of network traffic. Snort effectively detected this attack, generating multiple alerts from the flood attack. Finally, I used the command terminal to conduct an SSH attempt to the Ubuntu server. Snort successfully detected and logged the attempt, triggering an alert we defined earlier. After initial testing, I fine-tuned my snort rules to reduce false positives and improve detection accuracy. This involved adjusting the thresholds for each rule. For example, I limited a count for the flood attack rule to ensure that only a normal amount of alerts would be logged if potential malicious traffic was detected. From this project, I learned the importance of setting up and tuning the IDS correctly to monitor network traffic effectively. I gained practical experience in creating and optimizing snort rules, simulating real-world attacks, and analyzing alerts to improve the overall security posture. This project also highlighted the need for ongoing tuning and monitoring as network environments attack patterns consistently evolve. Thank you for watching.